First, let me show you what goes wrong if you try to use the same key multiple times. So here I've got our clock image, and I've got a sequence of random numbers generated from a key, and as we saw, the XOR of those two things gives us something that looks like noise. There's no clock in there that you can see. I can do the same thing with the picture of the house, use the same random numbers, and I get another sequence of random numbers that, when we look at it, we can't tell the difference. They both look just like noise. What happens, though, if I take these images that were generated using the same key and XOR those two together? This is something that an attacker would be able to do. If you do that, you get a picture that's not noise anymore. It's not our original messages, but it's an awful lot of clues about those messages. You can see that there's a house involved, and you can see that there's some sort of circle involved. So why did this happen? It's because XOR is its own inverse. We started with a plain text clock and XOR'd it with the key sequence. And we started with a plain text house and XOR'd it with the same key sequence. That's how we got the encrypted clock and the encrypted house. When we take those two encrypted things and XOR them together, that's the same thing as this expansion, where the unencrypted clock is XOR'd with the keys, XOR'd with the unencrypted house, XOR'd with the keys. Since XOR is commutative, we can swap these two around. And since anything XOR'd with itself is 0, we can simplify this term to 0. And then since 0 XOR'd with anything is just the other thing, we end up with the plain text clock XOR'd with the plain text house. That's this picture here, and that's why we get some information out of it. The consequence of this is you cannot use the same key with this style of encryption to encrypt two different things. Instead, you need to use a different key every time. And that can create some trouble. Somehow Alice and Bob will need to negotiate new keys every time. One idea you might have is that you'd have just one key that Alice and Bob know, and then you get a new key just by adding 1 to the old key every time. So then Alice and Bob both know that they should do this. The problem is an attacker also would know that they are following that strategy. And some kinds of random number generators, if you use related keys, they might end up generating related sequences of numbers. It really depends on your random number generator. So only do this sort of thing if your random number generator specifically says that it's okay to use it in this way. And we will see one such random number generator that says you can use it that way. It's the cha-cha algorithm, but otherwise just don't do this. It would be an example of misusing your cryptographic tools if you do this without the right kind of random number generator.